Okay, let's look at combustion reaction practice part 1. This is the first part of a series of questions that we're going to use to help review combustion reactions. So after you've tried this yourself, if you have questions, you can always come back and look what I did. A 0.537 sample of a substance containing only carbon, hydrogen, and oxygen was burned in air to produce 1.030 grams of carbon dioxide and 0.632 grams of water. What is the empirical formula for the original substance? So this is obviously a combustion reaction problem because we have a substance. It is composed of carbon and hydrogen, and in this case oxygen. It could be different. We have our two products, carbon dioxide and water. So the very first step that you're going to want to do is convert the mass of carbon dioxide into the mass of carbon. So I'm going to write down my given here. 1.030 grams of CO2. So this first step here is going to be going from grams of CO2 to moles of CO2. So I'm going to put 1 mole of CO2 up on the top, and then the gram formula mass of CO2 is 44 grams of CO2. And now I'm in moles of CO2, but I don't want to be in moles of CO2 because in the end, I just want to figure out the mass of the carbon. But I know that for every 1 mole of CO2, there is 1 mole of carbon because the subscripted number that's assumed to be here is 1 to 1. So now I'm in moles of carbon. And the last thing that I want to do here is go from moles of carbon to grams of carbon. 1 mole of carbon is equal to the atomic mass of 12 grams of carbon. And then I'm going to solve for my answer. But I am going to make sure that my units cancel before I do this because that is just good practice. So grams of CO2 cancels grams of CO2, moles of CO2 cancels moles of CO2, moles of carbon cancels moles of carbon, and I'm left with grams of carbon, which is what I want at the end. And if I do this, I'm going to get 0.2809 grams of carbon. And I'm definitely taking this out at least 3 or 4 decimal places because I do not want to round at all. Step 2. So I just worked with carbon dioxide, now I'm going to work with water. Here I have a mass of water. So I'm going to write down my given. 0.632 grams of water. And just like I did up here, I need to basically get to mass of hydrogen. That is what I'm looking for. So I'm going to go from grams of water to moles of water. Moles of H2O. Now, the gram formula mass of water is 18 grams. Now that I'm in moles of water, I need to get to moles of hydrogen. So in 1 mole of water, H2O, I have 2 moles of hydrogen because I look down here and I see this 2. So that means there's 2 hydrogen atoms for every 1 oxygen atom that makes up this molecule of water. So 2 moles of hydrogen in every 1 mole of water. And that's a really critical step to be doing that right there. Finally, my last step is to say, well, in 1 mole of hydrogen, I'm going to have 1 gram of hydrogen. Again, just the atomic mass. We check our units. Grams of water cancels grams of water. Moles of water cancels moles of water. Moles of hydrogen cancels moles of hydrogen. And then finally, I find that my answer here is going to be 0.0702 grams of hydrogen. Now you have to be really careful here. You can't just say, oh yay, I've got carbon and hydrogen, let me write an empirical formula. Because here they say, this sample is containing carbon, hydrogen, and oxygen. Don't forget the oxygen. So we have a total sample amount right here, and that is 0.537 gram sample. And we're going to subtract out the carbon, and we're going to subtract out the hydrogen. And when we subtract out these two numbers, we get our mass of oxygen, and that is going to be 0.1859 grams of oxygen. All right, so I'm good. I've got masses of carbon, I've got masses of hydrogen, and I've got masses of oxygen. So now I could take it to the next step and I can write the empirical formula. Okay, so here's my masses that I just found. My mass of carbon, my mass of hydrogen, my mass of oxygen, because what they want here is an empirical formula. So the first step is the AP Chem mantra, convert to moles. So if I'm going to convert grams of carbon into moles of carbon, then it's going to be 1 mole of carbon over 12 grams of carbon. Converting hydrogen, it is 1 mole of hydrogen over 1 gram of hydrogen. And finally for oxygen, 1 mole of oxygen over 16 grams of oxygen, because I'm just looking at individual oxygen atoms. Now I need to find how many moles do I have for each one. So if I do this for moles of carbon, I'm going to have 0.0234 moles of carbon. For hydrogen, I'm just going to basically repeat what I just had. So I'm going to have 0.0702 moles of hydrogen. And then finally, for this one, I'm going to have 0.0116 moles of oxygen. All right, so I've gone from mass to mole for each of these. The next step is to figure out which one is the smallest one and divide everything else by that smallest number. So I look at these numbers and I say, hey, you're the smallest number right here. So 0.0116, divide this one by 0.0116, and divide this one by 0.0116. And what do I get? Well, for this one I get 2, for this one I get 6, and for this one I get 1. Now what do these represent? These represent the subscripts of each of these elements in the empirical formula. So the empirical formula here would be C2H6O1, or more specifically, just C2H6O. That is my empirical formula. So these numbers right here, again, are subscripts, and these subscripts will go with each of these elements that we see up here. And therefore, you've answered your problem of what is the empirical formula of this particular substance.